Good morning, my dear student, and welcome to my channel, that is Easy Chemistry by SBG. Today we will learn the Kohlrauschs Law. The Kohlrauschs Law is also called as the Kohlrauschs Law of independent migration because at the infinite dilution of an electrolyte, each ion, that is cation and anion, migrate towards the oppositely charged electrode independently to its co-ions. That is why it is called as the Kohlrauschs Law of independent migration. The statements of the Kohlrauschs Law is the molar conductivity of an electrolyte at infinite dilution is the sum of the molar conductivity of ions produced by the electrolyte at infinite dilution. We can write it as the nu infinite is equals to the n plus, that is the number of ions, and it is the cation infinite plus number of anions into the molar conductance of an anion at infinite dilution. So nu C at infinite and nu A at infinite are the molar conductivities of cations and anions. The molar conductivity of cation and anions at infinite dilution, where n plus and n minus are the number of cation and number of anion, number of cations and number of anions respectively. The multiplication of number of ions with molar conductivity of a particular ion is called the molar ionic conductance. That is the n plus into nu C infinity is the molar ionic conductance of cation. It is the molar ionic conductance of cation, while n minus into nu A infinity is the molar ionic conductance of anion. Molar ionic conductance of anion. In terms of equivalent conductivities, Kohlrauschs law is defined as the equivalent conductance. The equivalent conductivity of an electrolyte at infinite dilution is the sum of the equivalent conductance of the cation and anion. So the equivalent conductivities we can write in terms of equivalent conductivities. The Kohlrauschs law is stated as the equivalent conductance at infinite dilution is equals to the equivalent conductance of the cation plus the equivalent conductance of anion at infinite dilution. The lambda C and the lambda A are the limiting equivalent of or the ionic conductivities of cation and anion respectively. The applications of the Kohlrauschs law are as follow. Applications of Kohlrauschs law are as follow. First application of Kohlrauschs law is to calculate the molar and equivalent conductance at infinite dilution. This law is helpful in calculation of molar conductance at infinite dilution for weak electrolytes. Suppose we have to calculate the limiting conductance for the acetic acid. Acetic acid is an weak electrolyte. Then according to the Kohlrauschs law, molar conductance at infinite dilution for the acetic acid is equals to the molar conductance at infinite dilution contributed by the acetate ion plus the molar conductance at infinite dilution contributed by the cation, that is H plus ion. This equation can be obtained by the knowledge of molar conductance at infinite dilution for some strong electrolytes, that is sodium acetate, hydrochloric acid and NaCl salt. So again, according to the Kohlrauschs law, the molar conductance at infinite dilution for the strong electrolyte, that is sodium acetate, is equals to the molar conductance at infinite dilution of acetate ion CH3COO minus plus molar conductance at infinite dilution produced by Na plus. In the second strong electrolyte, the molar conductance at infinite dilution of HCl is equals to the molar conductance at infinite dilution by H plus ion plus the molar conductance at infinite dilution by the Cl minus ion. The third one is the molar conductance at infinite dilution for the sodium chloride is equals to the molar conductance at infinite dilution by the Na plus ion plus molar conductance at infinite dilution by Cl minus ion. The above equation can be obtained. The above first equation, you can give the number for this equation. This first equation can be obtained by adding the equation second and third. By adding the equation second and third and subtracting the equation 4 from them. It is by adding equation 2 and 3 and subtracting equation 4 from them. So molar conductance at infinite dilution for the acetic acid is equals to the molar conductance at infinite dilution of sodium acetate COONA plus molar conductance at infinite dilution by HCl minus molar conductance at infinite dilution by NaCl. So practically it is possible to calculate the molar conductance at infinite dilution for the strong electrolyte, then to measure the molar conductance at infinite dilution for the weak electrolyte. So by using Kohlrauschs law of independent migration, or by these equations, we can calculate the molar conductance value for weak electrolyte by measuring the molar conductance at infinite dilution value for the strong electrolyte. This is first application of the Kohlrauschs law. So let us see a problem. The first problem is the molar conductance at infinite dilution for NaCl, HCl and sodium acetate are given, that is 126.4, 425.9 and 91.0 Siemens centimeter square per mole respectively. Calculate the molar conductance at infinite dilution in Siemens centimeter square per mole for the acetic acid. This is our first application of the Kohlrauschs law. Options are given here. First option is 390.5, second option is 180.3, third option is 420.2 and fourth option is 350.5. So let us calculate. According to the Kohlrauschs law of independent migration, we know the formula, that is molar conductance value at infinite dilution for the acetic acid HAC is equals to the molar conductance value at infinite dilution for the HCl plus molar conductance value at infinite dilution for the NaCl, sodium acetate NaAC, minus the molar conductance value for the molar conductance value at infinite dilution for the NaCl. We know that values, so put up the values, that is 425.9 plus the lambda m at infinite dilution for sodium acetate is 91.0 minus molar conductance at infinite dilution for sodium acetate is 126.4. So 126.4. After calculation we get the value, that is 390.5. Unit will be the Siemens centimeter per mole. So first option will be the correct one. The other applications, that is the calculation of degree of dissociation, then calculation of ionization constant, and the solubility of sparingly soluble salt, we will see in the next lecture. Thank you. If you like my video, then please share, subscribe, and press the bell icon, so whenever I add the new video you will get the notification. Thank you.